I'm going to hand back a lot of homework at the end of the class, and you will all be very, very pleased because some of you got 225%. Yes, that's right. That is because I am terrible at writing questions, and I don't realize it until I read how some other people might interpret those questions, and I realize, oh yeah, you can totally interpret it that way, but that leads to the wrong answer. And so if you gave the wrong answer to one of these terribly written questions, I did not penalize you for it. But if you gave the right answer to it, I gave you extra credit. So that's why I'm going to be handing you back one assignment that I think had like 10 questions on it, and I graded it out of 4. Because there were actually only 4 questions. You guys, as I mentioned, are my guinea pig here for this program. So I was going to say your loss is the next year's gain, but honestly, you've gained quite a bit from all of these questions magically becoming extra credit. Yeah, so I guess your gain is their loss.
Yes.
But I did want to go over some stuff. So I used some vocabulary in assignment 6, which is the one, I think that's the one with the bent rock layers. And I realized that the vocabulary is not used anywhere in the article, and we hadn't covered it in class. So I'm introducing it now. These are 2 terms that are going to come up a lot, and they are creationist and evolutionist. And they refer, in case it isn't obvious, to people who believe that God created the universe and people who believe that the universe and earth and life just evolved. And within these groups, there are subgroups, if you will. There is the young earth creationist, and young earth creationists believe in the Bible is true. I'll just put that. The Bible is true. So the Bible says the earth is about 6,000 years old, and young earth creationists say, yeah, that's about right. The old earth creationists I would label, if you will, as compromising Christians. So these are people who believe in Jesus and really want the Bible to be true, but they are convinced that actually the earth is not young. They're convinced that the earth is old. So old earth creationists, they believe God made the world and God saves from sin and all that, but they don't recognize the problem inherent with assuming that God used evolution to make the earth. So the creationist camp is generally Christian, either Bible-believing Christians or compromising Christians. In the evolutionist camp, there are the evolutionist group. There's also 2 camps, if you will. I'm sorry if I'm using weird words like camp. But under the heading of evolutionists, you have theistic evolutionists, which believe that God did have something to do with how the world came to be. But they don't have a necessarily Christian perspective. They rather simply look around at the world and they say there was no way that this came around by chance. Some intelligence designed this world. But that's about the only thing that really unites them, is that some intelligence designed it. And so they believe that this intelligence, this God figure, used evolution to make the universe what it is. So they're not necessarily Christian, but they do definitely share a lot in common with old earth creationists. And certainly in the scientific battle of creation and evolutionists, the intelligent design gang can sure come in handy sometimes. They're good allies to have, even if they're not Christian and we don't agree with everything. And then, of course, you have the atheistic evolutionists, which I guess I'll just put Darwinist there. Do you guys know who Darwin is? I keep using that phrase Darwinist, and I don't know if I've ever talked about him. I might have. Yeah, Charles Darwin is known as the father of evolution. He's revered basically as a prophet by those who embrace evolution. He is the guy who wrote the book On the Origin of Species. We might talk about him again tonight, so I'll write him down. His first name is Charles. Huh? Yeah, he's. I mean, if you want to play good guys, bad guys, he would be a bad guy. Yeah, it's never quite so black and white. But he wrote 2 very important books. The first one is called On the Origin of Species. It actually has a much longer title, but everybody just refers to it as Origin of Species. And this is where he discusses natural selection as he has understood it scientifically. And honestly, the majority of it is decent science. But what leans into speculation is when he tries to use natural selection as the mechanism that goes all the way back to a single-celled organism at the beginning of all life. So he kind of makes the uniformitarian assumption where he observes a little bit of changes happening in populations over a little bit of time, and then assumes that, okay, I bet the changes have always been happening like that, going all the way back to the beginning of time, millions and billions of years ago. He also wrote another book that is more controversial and thus less popular, but was actually a bigger deal at the time, and that's called The Descent of Man. And on The Origin of Species, Darwin knew that he was treading on dangerous cultural ground with his idea that all life came from a one-celled organism billions of years ago. So he was a little more cautious in what he said about that in this book. After he published this book, his idea became very popular and very accepted in scientific circles. So then he wrote The Descent of Man, which specifically talks about humans and how humans evolved from less human beings. So the idea was implicit in The Origin of Species, because humans are species too. But here's where he really dives into it. And this book has some very unfortunate stuff in it that we might get to talk about today, but to call it racist would be a horrible understatement. It's bad. So let's see here. I'm going back to my notes that I wrote on the, I forgot I wrote a backside to this too. Okay, so the notes I wrote on the homework, other than that, if you're curious, in assignment 6, I eliminated questions 2, 3, 4, 5, and 7 as unfair. So if you answered any of those correctly, you got extra credit, and if you didn't, it didn't hurt you.
Assignment 6?
Yeah, that was assignment 6, yeah. Have you not done it yet?
Wait. Oh no, I just have it because I haven't done the memory work for it, so then I need to memorize it.
Oh, okay, yeah.
Wait,
That
what
way I
numbers?
keep track of my memory.
Don't change anything.
I'm not changing, I was just...
Okay.
What numbers?
I indicated it on your assignments. I wrote a +1 or something like that if you got a right answer, but it's 2, 3, 4, 5, and 7. It's on the video, so go back and watch the video. We're like 10 minutes in.
Okay.
Assignment 7, sorry. Never mind, those are just notes for me. Okay, this is where, I wanted to talk about that, and... Okay, I want to talk about the bent sandstone layers as a evidence for the flood. You know what, I'm going to put that off because there's a whole lesson in our book called Evidence for the Flood, and so just remind me I want to review that homework assignment with you guys for that lesson. A lot of you seem to understand it, which is cool. A lot of you I wasn't quite sure. And some of that is because I asked terrible questions, and so when you ask terrible questions, you get terrible answers. So I don't know if you knew it or not, knew this stuff or not, but we'll review it again because it's it's pretty cool evidence in favor of a worldwide flood, which of course is strictly denied by evolutionists of all kinds, because that would mean that all of their precious evidence for an old Earth is actually evidence for a recent flood. And they don't want to admit that. Elliot?
Would this mean that old Earth creationists would also be against the idea, or not?
So old Earth creationists are, I kind of get the feeling that they would rather not believe in an old Earth, but they kind of feel like they have to, because they've been convinced. So I don't know if old Earth creationists would necessarily go against the idea of Noah's flood. I think they're already convinced that it didn't happen. So they might be a little more receptive to hearing that it did happen, but every person's an individual, so I can't really paint them all with the same brush. This is just kind of the general, what I've observed in conversations is people in the creation evolution debate tend to fall somewhere along this spectrum, going from atheistic to biblical. Okay, so we are on page 62 of your book, so you can go ahead and turn there. Last time, remember, we talked at length about uniformitarianism. Who remembers what uniformitarianism is? Elliot.
The belief that something is consistently happening, even though it went back super long. Like if the Earth was moving 2 inches every year, it was the belief that Earth had then kept moving 2 inches every year back billions of years ago.
Very good. Yeah. So to put that in simplified terms, I understand what you're saying, or not simplified, but the technical definition of uniformitarianism would be that current rates of change, currently measured rates of change, can be assumed to be the same throughout all of history. So as an example, Elliot mentioned something that's measured to be moving 2 inches per year. And so going backward, then you can assume that 100 years ago it was 200 inches to the left of where it is now, and a million years ago, you know, it was onward and so forth. So, for example, we observe continental drift at a rate of this is a good one to graph. I like graphs, and I've never actually drawn one for you guys because you don't get many opportunities in confirmation class. But here is an example here. So in science, if you've got time on an axis, it's always on the horizontal one there. And then over here, we're going to say movement and keep it vague here. So this is a graph of continental drift. What actually is observed, so from like, I'm just going to make up some numbers here, but it's something like this. So like from 1900 to 2000, we observe, those are way too far apart. Whatever, it's just an example. From 1900 to 2000, we observe that that it moves this way. I should have it up here. Whatever. No, I shouldn't. This is right. So from 1900 to 2000, we observe, 6 feet. Continent drift 6 feet east. Sure.
It's a lot of feet.
Yeah. It's over 100 years, though. 6 feet in 100 years, that's
like how tall I am.
That's almost beach erosion. But in any case, it is observed that the continents drifted 6 feet to the east over the course of 100 years.
Oh, that's
and so what a uniformitarian would do is say, okay, so, Elliot brought up Pangea back when we had our guest speaker. A uniformitarianism would say, okay, so we know every 100 years it moves 6 feet. So, so way back here is going to be, 10,000 BC, sure, 10,000 BC, and we see that that the continent was actually all the way here in 10,000 BC, and if and you'd have to extrapolate way farther back, way off the scale of my graph to get to 18 million years ago. I just threw that number out, 2 billion years ago. And it would be, on the other side of the world at a rate of 6 feet per century. But then that's the uniformitarian assumption. But the history, as we believe it, under with the way the flood operates, and we're open to change on this scientifically. But what we propose as people who believe in Noah's flood is more something like this, where the continents move. This would be about Noah's flood. So I'll go ahead and put Noah's flood right here. This is, what is this? About 2500 BC, I think. So right about here would be where the continents were really moving. Noah's flood, the great fountains of the Great Deep burst forth. That's like volcanic activity. Tectonic plates got pushed. Stacy Lung drew something like this, where you have a single tectonic plate that's cracked, and then you kind of have it, one side of the crack gets pushed up this way, and the other side of the crack gets pushed up this way. You got all this magma and whatever shooting up there, and meanwhile, the plates themselves are sitting on top of liquid. And if you've ever done something, you can imagine if you have two rigid things sitting on top of liquid being pushed like this, they're going to slide apart like that. And so that's what ends up happening, is these pieces slide apart farther and farther away. At first very quickly. Now when I say very quickly, I mean I think Stacy Lung said about the speed of a person walking. So, not really fast, but quite a bit more than 6 feet per century. And so that was an incredible amount of energy released that got the continents moving. But the continents are really big, and they don't have far to go before they crash into a different continental, or tectonic plates is what these things are called. We've got the tectonic plates moving, but they can't go very far before crashing, and so a lot of energy is lost with the collisions. You get earthquakes, you get subductions, you get all kinds of fun stuff. Mountains are formed, so they do slow down pretty quickly. But you notice that the rate of change that we observe in our 100 years of observation is very different than the past. And you would never know. The reason why I drew both of these as dotted lines is because they are both assumptions. The truth is we don't know what happened before we started measuring things. The uniformitarians say because we don't know, the best we can do is assume that it's always been that way. But we say that's a stupid assumption to make. There's no reason why it should be that way, and the history in the Bible would strongly suggest a different cause. But again, it's a strong suggestion of a different cause. But the reason why we focus so much on the flood of Noah's day as an important historic event is that it explains so much of geology, which long earth or old age scientists, evolutionists and their ilk, they say is evidence of millions of years. And we say, no, it isn't. The exact same results could be obtained if there were a flood 4,500 years ago, as opposed to millions of years of the exact same thing happening. So yeah, I drew the uniformitarian assumption in red because we don't like it. It's not very good science, and people cling to it religiously when really, we've only been measuring this kind of stuff for, a couple centuries tops. How are you going to measure with instrumentation from the 1600s? How are you going to measure continental drift? They didn't even know there was such a thing back then. Watching, yeah, you can't, we're talking 6 feet a century. It's literally inches per year.
The Earth is moving thousands of miles per hour as well.
Well, that's moving around the sun and stuff, yeah. Everything is moving or stationary depending on how you define your reference frame. That's a fun fact. There actually is no one object that can be said to be staying perfectly still. Every speed is defined relative to other things. So for example, if a car drives past you, it's going 60 miles an hour, but if you're in the car, the pedestrian that you swing by is going 60 miles an hour the opposite direction. It's all just a matter of, it's all relative in terms of speed. Only when you're getting super fast to the speed of light does it start to matter. But that's neither here nor there. Speed of light's a little beyond this course, but not much, because today we're going to be talking about the Big Bang, unless I have something else to say here. Nope. Okay. Let's talk about the Big Bang. This is page 62 in your book. Big Bang or Big Bust? The Big Bang theory states that all matter in the universe was compressed into a small point until it finally exploded. But is the Big Bang really just a big bust? Below are some of the problems with the Big Bang theory. So one of the things I don't like about your book is that it doesn't actually teach evolution. It just teaches what's wrong with evolution. And I feel like that's dishonest. So I want to at least cover the basics of the Big Bang theory. What do you guys know about the Big Bang theory?
Nothing was there, and then it was there.
Nothing was there, and then something was there. Okay, it just happened, I heard Addison say. What else? Anybody watch the Big Bang Theory show? I know the theme song. The whole universe was in a hot, dense state of music. And then it kind of goes crazy after that. But that is how the Big Bang Theory starts. The whole universe, all matter in existence, was condensed to a tiny point. That was at the beginning. And then something caused that point to explode outward. But this is not like a really, really intense bomb. This is, it's hard to explain. It's not just all the matter in the universe. It is space itself was condensed in such a tiny point. Do you guys know, have you heard the idea that the universe is expanding? That idea kind of comes from the Big Bang Theory, because we've noticed by looking at the stars, there's this phenomenon called redshift, where we see wherever we look in any direction, everything is a little bit redder than we would expect it to be. And what that means is that it's moving away from us, because when things move away from us, the wavelength of light gets a little longer. It moves toward the red end of the spectrum. This is, whew, sorry, I guess I wasn't prepared to talk about all of the Big Bang Theory.
So is it true?
So here's there's one of two options is true. The first one is that Earth is at or very near the center of the universe, and everything else in the universe is moving away from Earth, and Earth is in a very special place in the middle. That is what they call anathema to evolutionists. They do not want to admit there is anything special about Earth. The whole philosophical underpinnings of atheism state that there is nothing special about humanity or Earth or anything. We are just meaningless conglomerations of molecules stuck on a rock floating in the vastness of space. And
that's a dark way to perceive it.
Yeah.
that is, that's nihilism. Remember when I defined nihilism? That's where that comes from. There's no purpose, there's no meaning, and there's no God. There's nothing that assigns that meaning. Humanism likes that too. That's like a happy atheism. Humanism says that we get to decide our own meaning. But the whole point is that there is no God who made us. And if we are in a favored place in the universe, then that's very, very bad for atheistic philosophy, because that would mean that there's something special about us, and there shouldn't be. So how do you explain everything moving away from us if we're not in a special place? Which I would posit here that, Christians have always thought that we are in a special place. Granted, they used to think that Earth was the center of the whole universe, and the whole thing with the Earth revolving around the sun was a little bit controversial. But to hear that our galaxy might actually be at the center of the universe is, it kind of harkens back to those days where God put us there because he loves us, or some drivel like that we can't tolerate in science. So if we aren't in the middle with everything moving away from us, then the only other way to explain it is that everything is moving away from everything else, because space is getting bigger. And if space is getting bigger, then, you and I are 6 feet apart now, but in a million years, maybe we'll be 7 feet apart or 10 feet apart. We're moving away from each other. And so that constant movement away from each other would make you look a little bit redder to me, because that's an observed reality. If you move something away from something else, there is a red shift. And I'm sorry that I don't have time to explain why that is, but you gotta take my word for that. Redshift is real, it's happening, everything is moving away from Earth, and the only explanation is either Earth is in the middle and everything is moving outward, or everything is moving away from everything else. And because the atheistic scientists cannot admit that Earth is special in the universe, they have to go with the idea. They liken it to being on the surface of a balloon. If you imagine that you're on the surface of a balloon, so here we have a deflated balloon or a very low inflation. You know how it is. The balloon gets about this big, and then you gotta really, put your lungs into it. And if you have 2 points on the balloon when it's only kind of inflated, and they're like this far apart, whatever, that looks like a face. And then you blow up the balloon, and now it's like, really big. Those same 2 points are going to be much farther apart, right? And so this is, I forget what the principle is called. It's not called inflation. Inflation is different. But this is kind of the observed evidence. This is kind of the interpretation of the observed evidence of the Big Bang Theory. So if everything is moving away from everything else, that means space itself is getting bigger. That space, is getting bigger, like the surface of a balloon is getting bigger. And because of uniformitarianism, if we know everything is moving farther apart, you go back in time, and there must be a time when it was all closer together. You follow me on that, at least? If everything is moving farther apart into the future, then everything is moving closer together into the past. And so you keep on going into the past, and eventually the whole universe is in a hot, dense state when nearly 14 billion years ago expansion started. Wait, and pyramids and something. Yep, I should have probably memorized that song before tonight.
Oh, good luck.
And so that's the idea. So within this hot, dense state is not only all the matter and energy in the universe, but also space itself. And technically they would call it space-time, but that's physics that I don't even fully understand. So we'll just call it space and let that be good there. So, that is the Big Bang Theory, and now that I feel I've given you an age-appropriate explanation of the Big Bang Theory, I've tried to keep it like below college level, so I'm sorry if I lost any of you. We're going to bring it back to Christianity now. What are some things that you can see are maybe wrong with the Big Bang Theory? Just looking at it as an intelligent human being.
How did like you know how our world like has like the air bubble thingy like
Atmosphere?
yeah,
Uh-huh.
how did that appear from the little thingy?
Okay, well, to that I have to be more charitable to the Big Bang theorists and actually explain it. So the idea is, I'm going to move my hot dense universe to the left here to be the beginning of time. As expansion started, everything moved around, and for a while it was all just these crazy hot gases, just flying away from each other, flying away from themselves, and everything was super condensed and super hot. Eventually, the force of gravity begins to take over, and clouds of gas kind of start coming together and wanting. These are huge clouds. These are like the size of galaxies, right? And over time, the clouds of gas condense down and become stars. So I'll go ahead and just draw actual, like elementary school stars on the board. And these stars themselves, if you zoom in on one of them, they attract clouds of gas kind of orbiting around them, because gravity wells, like if there's a whole lot of gravity, everything kind of swirls around it like a whirlpool. That's what a whirlpool is you've got gravity in the drain in the bathtub, and all of the other stuff in the bathtub swirls around it. And it does eventually, come into it, but that takes a while. And when you're on this kind of scale, that takes a very, very long while. But supposedly, the clouds of dust formed around stars, and eventually the clouds of dust condensed as well into planets that continue to go around their stars like that. And then if you want to get into how these planets formed, they used to just be a ball of rock, but I don't even know what happened. Yeah, I mean, you could say that maybe some of them had water, or they were hit by comets that had water in them. But then, like, where did the water from the comets go? And there's lots of crazy ideas on how water came to Earth. But that's the gist of it. This story. Elliot?
I think like one problem with like the Big Bang Theory is like there's so many different theories on how it happened. Like you can't just stick with one major idea that everyone agrees on. Everyone thinks like a different thing. Mm-hmm. Like from what I've heard, instead of like the clouds of gases surround stars, I've heard that the stars explode into like solid rock, and then they all crush together and make planets.
Yep. That's yes, and it's I didn't even talk about stars exploding, but that could fit into it as well. So you could call it a weakness. We don't know. You can call it a weakness that we don't know a lot of this stuff. And the thing is that they would admit it. The people who believe in this stuff are like, yeah, we don't know exactly how it happened. But they kind of hedge on that a little bit. But they are confident that it happened more or less this way, and also confident that as human knowledge improves, our theory will improve. But you got to remember that for a humanist, their faith is not placed in any one scientific theory. Do you remember where the faith of a humanist is actually placed? What do they have faith in? What is their God?
Humanity surviving or humanity thriving.
Humanity, yes. So their faith is in humanity. You've probably heard the cliche, faith in humanity restored, or I lost my faith in humanity, something stupid like that. That's like humanist thought. That's a really stupid thing for a Christian to say earnestly. I mean, if you want to make a joke, make a joke. But if you like earnestly have faith in humanity or something, Christians shouldn't have faith in humanity, because we know that humanity is sinful and doomed to die, and just like we can do a lot better than humanity. But when you're a humanist, humanity is all you got. So to lose your faith in humanity was actually kind of a big deal for them, which is why it became this joke, because it's funny to make a big deal out of silly things. So we don't know, but humanists don't care. I'm going to put atheists don't care. Atheists don't care. Humanity will learn. But for us Christians who like to actually know what happened, we have our Bible that tells us, and we like that. But that's because we have faith in God and in His Word. What I kind of want to get at with problems with the Big Bang Theory that you can just spot right off the bat are the ones printed on page 62. So, I mean, good job not just parroting what's written out for you in plain English there. The Big Bang can't explain where the stuff in the universe came from, right? So, if I ask, where did the universe come from? And an atheist says, well, the Big Bang Theory. The whole universe was in a hot, dense state, and before, I'd be like, wait, stop. The whole universe was in a hot, dense state. Where did this come from? If I ask you where did the universe come from, and you start with the whole universe was in a hot, dense state, I'm going to be like, hang on, whatever you say next doesn't answer the question. All it does is push it back. So where did the matter come from? What caused the Big Bang? These are questions that the Big Bang Theory can't answer. And they are important questions because it matters where we come from. That gives us purpose and all of that. So if your theory of where everything comes from starts with a thing, then that's not really a theory of where everything comes from, because you've got a thing and you don't know where it came from. And they can't say that it's infinite. So an atheist could say, well, you don't know where God came from. You just say that God has always existed. And I'm like, yeah, that's right. God actually created time, so God exists outside of time. But this thing exists inside of time, or rather, it is time itself. And we know by observing things that happen in time, there's this thing called the second law of thermodynamics. I almost just want to skip that. But it's the second one on the page. Please do. Are you tired? Yeah.
Oh no, it's a big topic.
I've
just talked about this in science.
Oh yeah, nice, yeah.
We did. What is it?
All right, I'm not going to quiz you on what the second law of thermodynamics is, but here's the principle behind it. Stuff breaks. That's it. Stuff breaks. If you work really hard to build something beautiful, you have to work really hard to build something beautiful. But how hard do you have to work to destroy it?
Not very.
Not very, right, if at all. And that is the case of the whole universe. The universe prefers chaos. The universe prefers disorder. If you're going to throw a bunch of crap in the air, 99.999% of the time, you're going to end up with a bunch of crap on the ground. Maybe, if you get super lucky, one of those times, the crap will fall out in a way that is actually ordered or useful. But that would be an extremely rare occurrence, and also an extremely fragile state for it to remain in. If you throw a bunch of stuff in the air and it lands into something beautiful, you can be sure that the first wind that comes along is going to knock it over, and it will once again be a pile of junk. And that is essentially the second law of thermodynamics in action. Everything tends toward disorder. And if you want to create order somewhere, you actually have to take order away from somewhere else. So the friction of building and the chemical losses in your muscles as you move, all of those things create more disorder in the universe, and that has to be spent in order for you to build a little bit of order out of whatever project you're working on. Does that make sense? So the universe as a whole falls apart, and it turns out scientists have found a way to quantify that mathematically. And I'm not even going to write the equation on the board, but that's the second law of thermodynamics, is in order for anything at all to happen, anything that happens, me moving my hand, me talking, the sound waves traveling to you, all of that must follow the law that says the universe tends toward greater disorder, greater chaos. And there's entropy is the fancy word for chaos, and then there's enthalpy, which has to do with heat. And the two have an interesting relation, and that's thermodynamics in a nutshell. All that to say is that all of these steps after the Big Bang don't happen. We've never observed something like this happening. In what universe does stuff that is flying apart in random disorder decide instead to come together and make order? not this one. That doesn't happen. We don't observe it happening in space today. And if you say that to them, they'll say, "Oh, well, it happens so slowly that it's it's not observable in present time scales." But yeah, we just don't observe it. We observe clouds of gas. This is what happens. Is we look out with our telescopes and we observe clouds of gas out there, and we observe stars that are surrounded by disks of rock, and we observe stars exploding, which I didn't draw on the board, but it's there. We observe all of these various stages, and we assume that they must be related, that there must be an arrow going from this one to this one to this, that there's an order to these things. But that's a big assumption. It's equally likely that the way we see the universe is just the way God made the universe. And there's no reason to think that one has to lead to the other, and that's what led to us. Again, it's a case of making a observation over a short period of time and assuming that it must be true for all of time. It keeps coming back to that, the uniformitarian assumption. It's a really bad thought process to think that way. And then the third little circle there on your page is basically the same as the second. It's just a little differently spoken. The precision and order of the universe speaks against the random disorder that would be caused by a Big Bang. So again, if there were a Big Bang and hot gases were flying apart from each other, they would keep flying. They would not be organizing themselves, certainly on a stellar scale, which means on the level of stars, but also not on a planetary scale either. I've dumped a lot on you today, and I appreciate you sticking with me here. I want to go on page 53, but 63, sorry. Yeah, 53, I don't even know what's there. Okay, the top half of page 63 is kind of the same objection I've had to this from the beginning. So the Big Bang Theory is the beginning supposedly of the whole universe, and there's a lot of opinions on that. But there's also a lot to say about the origin of life. That's getting back to Charles Darwin, because he was not really an astronomer. I mean, he probably had a telescope or whatever, but his stuff here is not about astronomy or cosmology or whatever. It's about biology. It's about life, and so in the creation evolution debate, we have the whole cosmic thing with all the planets and stars and everything, and then we have the debate that's local to the Earth, namely the origin of life. And you could maybe talk about the origin of the planet itself, but that leans more into the cosmology side of it. So we got to talk about the evolution of life as well. And there is another law called biogenesis, which, I mean, you probably know that Genesis means beginning, and bio means life. So biogenesis is how life begins. And the law of biogenesis states that life comes only from other living things, right? So people don't just spring into existence. We have to be born of the union of other people. And that wasn't always believed. This is a fun story. So it used to be believed that fruit flies just appeared. Did you know that? Because if you leave fruit out, one day it's going to be full of fruit flies. Where did the fruit flies come from? Did somebody let them in? I don't think so. They just magically appeared. And they didn't have microscopes in those days, so they couldn't dig down and see, little fruit fly eggs in the fruits. And so it was believed for a long time, especially by atheistic scientists, that the fruit flies just appeared. It was called spontaneous generation. Spontaneous is a fancy word that just means it happens. And generation means, something is generated. You know what generation means. And so that was the idea. And I forget who the scientist was, but there was a scientist who finally laid this to rest. And this is what he did. He, I think it was just water. Do fruit flies just appear from water? I think they can. So this guy just used water. And he had two sealed containers. So we're going to pretend like this is a lid on top here. And this is good science too, so this is why I get excited about it. This is what happens when people actually do science the right way. 2 containers, fill them with water, and sealed them so there's nothing getting in. I don't know how to depict a seal there. It's like I don't know what that is, like a clamp holding the lid down. Nothing gets in, nothing gets out. And then what he did was he put fire under one of them. Look at me, I'm gonna draw blue fire. Silly me. He put fire under one of them, and he boiled it. This is like a really hot fire, yeah. So he boiled the water, but the water couldn't escape because it was sealed in there. All he did was boil the water, and he let it boil for some time, and then he stopped. He took the fire away, and he said, okay, and of course the water cooled back down. He said, okay, here's our 2 samples. They are identical in appearance. The only difference is that this one was boiled, thus killing anything that might have been living in there that we couldn't see, and this one was not boiled. And sure enough, after a bunch of time passed, fruit flies started appearing in the unboiled one, but there were no fruit flies in that one. And so that was one proof of the law of biogenesis, that life only comes from life. And this scientist, without the aid of a microscope, figured out that there must be some microscopic fruit fly eggs in the water that is causing fruit flies to develop. And when you boil the water, it kills the eggs. And that's exactly what was happening. So pretty cool that they were able to figure that out even without microscopes. And yeah, so that is the law of biogenesis. We've never seen a place where life arises spontaneously. It just doesn't happen. But the Big Bang Theory and the theory of evolution requires that life must have at some point arisen from non-life. That at some point the law of biogenesis was broken and something just appeared. They call this the primordial soup. I won't write it down, but I will draw a picture. So basically, there was this giant ocean on the surface of the earth, and there was all kinds of junk floating around in the ocean that were not living, but also happened to contain the building blocks of life. They would call these organic molecules. And then something happened. A lot of them think it was probably a lightning strike, but something happened to make these things come together in a very unique and special way, and from that came a very simple single-celled organism. And that's how life started. Now, it's very telling that with all of our advanced technology and science and whatever, we cannot even come close to making life form in a laboratory. Even when we're trying, there have been a lot of experiments that try to duplicate what they think was in the primordial soup, and then see if they can, charge it the right way with electricity to get some life to come up. But then there are also scientists who are actively trying to make life. They're like, yeah, we don't care about evolution. We just want to make something alive. And they can't. They can't. We have no idea how life can come about. So this huge assumption, the beginning of the whole evolutionary tree of life, is just that. It's an assumption. It has never been observed. We can't even theorize how it might have happened. The best we can do is say, I don't know, lightning struck. Frankenstein, That's a very old idea that lightning can just suddenly make things come to life. Like Frankenstein's monster, he needed a lightning strike to bring it to life. So so that is the first bullet point there on page 63, that chemicals in an early ocean combined to form single-celled organisms. Your body is made of chemicals, but you can't, there's no way to make those chemicals come together to form life unless they come from something else that's already living. The other idea, this was favored, I believe, by Stephen Hawking, he died recently. Yeah. So he contributed a great deal to physics. At least they think he did. I don't actually understand what he did. I'm not saying that it's not worth understanding. Just that I personally, it's a little beyond me. But he may or may not have contributed a great deal to the field of physics. But regardless, he eventually, I've read, came to the conclusion that there's just no way that that the conditions ever existed on Earth that would allow life to rise from non-life. But he was still a staunch atheist and refused to admit there was a God. So what he said instead was that life must have originated on some other planet that we don't know anything about. So the conditions there were good for life. And even though we can't imagine what those conditions would be, they must have been there. And then when life arose on that planet, it somehow made its way here. Maybe it contaminated a meteoroid and the meteor came to Earth, or maybe space aliens that are intelligent life actually planted life on this Earth as like a seed to watch it grow. And so Earth is kind of like a giant terrarium for some alien observer. We don't really know. That is called directed panspermia. The word pan, the prefix pan means all or everything, and sperm means seed. And yes, that is where the word for the human male seed comes from, sperm. But in Latin, it just means seed. So directed panspermia means that somewhere out there in the everything, in the cosmos, there is the seed of life, and that seed was directed to Earth. So that claims the first living cells on Earth came from beyond our solar system. Somewhere out there, life originated, and then it was brought here. Maybe aliens, maybe accidents, whatever. That clock is wrong, by the way. But we do have about 5 minutes left. And I think since I've dumped a lot of science on you and not a lot of religion, and this is supposed to be a religion class, I think I'm going to let you guys call it a night here. And I'll spend the rest of our time passing on homework and stuff like that. Tonight's homework, I'll describe that for you while I hand it out, is another article. I hope you guys are enjoying reading these articles because they are very good. And this one is written specifically about Neanderthals. I prepared it because I kind of thought we were going to get to this stuff more, but I'm pulling the plug on that a bit early. But Neanderthals, you might have heard, are ancient creatures that are kind of like apes, but not really. They're ancestors to humans. And of course, if that were true, if we have an inferior ancestor, then God did not make us from the dust of the ground, as your memory verse says, but rather God made us from something that was slightly less human. And so this idea of Neanderthals is not biblical, and it's also not very good science. And this article that I gave you focuses on the science of why Neanderthals are actually just an extinct race of humans, and not a precursor to humans. So you read the article. I hope the questions are pretty easy. If a question looks hard, just try to find some keywords from the question in the article, because that's what I'm hoping you do. I have some longer questions at the end. The questions are long because I want to give you lots of keywords that you can use to find the answer in the article. But the answers are fairly short in that, yeah. Okay, let me hand out graded homework. I did not organize these, so I'm just going to go around and hand out whoever's name is there.